Hello guys, this is Vishant. So welcome to your channel, which is Sci Engineers. So we are going to continue with the topic, which is friction. We have been already uploading videos for your engineering mechanics subjects, applied mathematics and basic electrical electronics. So if you are new to the channel, you can go and watch those videos. And also do subscribe to our channel and hit the bell icon to never miss a notification of the videos we upload. So let's get going. In this video, we are going to continue with our discussion for friction, in which we are going to take the topic which is wedge friction. Now, wedge is nothing but a block which is used for lifting of objects, or it can be used to support certain objects. So basically, wedges are nothing but a triangular shaped block which is being kept between two objects to support some objects or lift those objects. So let us go to the problem which is given to me. So we have two blocks which are A and B. In this, my B is considered to be a wedge which is being used to lift the block A from its position. So to do so, we are using this P which is going to lift the block A, and there is some weight which is being added on A, that is of 5000 newtons. We are given that the wedges and the block do not have any weights of their own. Their weights are negligible in nature. And we have been given the frictional coefficients between all the surfaces to be tan 15. So we have to calculate the value of the minimum value of P which will be required to just lift A from its position. So let us try to analyze what the problem is. So what is given is that my B is used to lift A with the help of this particular force which is P. The P over here is unknown force which is to be calculated. We can see that on A there is a 5000 newtons which is being added, and it is in contact with this particular surface, and it is also in contact with the wedge below it. So on all of those surfaces wherever there is contact, there is going to be a frictional force which is being generated, which will be proportional to the normal reaction. Now since we are calculating the minimum amount of force to just lift it up, so we want there to be some amount of motion to be present. So we are going to consider the maximum possible frictional force which we have to overcome. So at all contact surfaces, we are going to consider the frictional force to be of maximum nature. So the value for maximum frictional force is given by mu into N. Now when you are going for the FBD of different blocks, what you have to do is you have to first of all try to understand the number of variables which are going to be present. Whenever you are solving for wedge frictions, you have to understand that you can only have summation fx and summation fy as the two equations for solving purpose. The reason for not including summation m is because there are no distances which are going to be given in this particular case. So you don't have the distances which are available, the dimensions of the blocks given to you. So there is no possibility of having a summation m equation in this. So you have for one FBD you will have only two equations possible, that is summation fx and summation fy. So since you have only two equations, so you should have only two unknowns. So now let us try to analyze. If I try to draw FBD of A, the unknowns which will be present are the normal reaction from B and the normal reaction from this particular surface. So you can see that there are only two unknowns present, but while in the case of B, there is going to be normal reaction from A on it and normal reaction from this particular surface, and plus there is this unknown force which is being applied on it. So there are basically three unknowns to be determined. So it would be advisable to go for the FBD of A first and then for B. So let us try to draw the FBD of A. So FBD of A will be looking like this. We have this block A. There is this 5000 newtons which is acting downwards. Since A does not have its weight, so we will be not considering that weight. There is going to be this normal reaction from this surface, and there will be a normal reaction from this surface. Now when you are considering from this surface, it's going to be perpendicular to the surface. So you should draw it perpendicular to this particular surface. So let us name this as N1, this thing as N2. Now the remaining forces which you have to represent are the frictional forces. Now this is quite tricky because you have to understand that frictional forces are going to be always in opposition to the motion. So what you have to understand is that my B is going to move A upwards. So basically my motion of A is going to be in the upward direction. So the frictional force from this particular surface should be in the downward direction. And since we are considering the maximum frictional forces, so this will be equal to mu N1 because it is because of this particular normal reaction. Now when you are considering for this particular surface, you have to understand that P is going to move block B in the right direction. So because of that, you can see that on B, because of this surface, the frictional force will be in this direction. Because of A, the frictional force will be in this direction. Now when you are replicating this particular force on A, you can see that the frictional force should be equal and opposite, because this particular frictional force is represented for B. So when you are representing it for A, it should be equal and opposite. So this particular frictional force will be in this direction. So that will be equal to mu N2. So now what we have to do is we have to just represent the angles which the forces are making. This is already in the y direction, so no need for the angle. These are already along the x and y. The only angles which we should consider now are for these. So now from the figure you can see that if I draw a perpendicular over here and I draw this, complete this triangle, this angle is 20, if this is 90, this part will be 90 minus 20, so this will be 20 degrees. So I will be getting this as 20 degrees, and this thing will be 20 degrees again. Then we have to represent the equation. So we will be writing the equation as summation fx equals 0. So all the forces which are along the x direction should be represented over here. So that is going to be minus N1 because of this. Because of this, it's going to be plus mu N2 cos 20, and because of this it's going to be plus N2 sin 20, which is equal to 0. Rewriting the equation, you will be getting this as minus N1 plus N2 into mu cos 20 plus sin 20 is equal to 0. Now using the next equation, which is summation Fy, so you will be getting summation Fy equals 0. So all the forces along the y should be represented over here. So you are having these two forces. So you will be having this as minus 5000 minus mu N1, and the components are along the y-axis. For the mu N2, it's going to be minus mu N2, the sine component for it, and for N2 it's going to be the cos component but positive. This thing will be equal to 0. Then rewriting the equation, so you will be getting this as minus mu N1, then it's going to be N2 common, so that's going to be cos 20 minus mu sin 20 is equal to 5000. So solving 1 and 2, you will be getting the values of n1 and n2 from it. You know already that mu is given, so mu is to be taken as tan 15. So you will be getting the values of n1 and n2 by simultaneously solving them, then going for the FBD of B. So let us try to represent the FBD of B. So this is my block B, which is present over here. There is going to be this particular unknown force P from this direction. Now there is going to be the normal reaction from this particular surface, so let us name that as N3. And now since we had represented on A the normal reaction from B to A in this direction, that is upward direction, we have to represent equal and opposite the same N2, which is going from the downward direction. Then we had represent this frictional force which is going slanting downwards. So we have to show it slanting upwards, which is going to be of same magnitude, that is mu n2. Here also there is going to be a frictional force which is going to oppose the motion of B. So that is going to be mu n3. So we again need to represent the angles which the forces are making. So this is the angle which we need to consider. This angle is given to us as 20, so this angle over here for this particular force will be given to us as 20 degrees. So this angle is 20 degrees. Then same by geometry, this particular angle can be shown as 20 degrees. So now using your summation fx, summation fy, so summation fx equations, you will be getting it as your P, which is the unknown force, then minus mu n3, then the component of these two forces, so that is going to be your minus mu n2 cos 20, and from n2 it's going to be minus n2 sin 20. This thing will be equal to 0. Now in this we already know n2 from this, so I'll be rewriting the equation as P minus mu n3 will be equal to n2 into mu cos 20 plus sin 20. So substituting the value, you can rewrite this equation. So let this equation be 3. Next we can go for the summation Fy. So summation Fy, all the forces along y direction, so that is going to be this n3, which is positive. Then the component of these forces, so that's going to be minus n2 cos 20. Then from here it's going to be plus mu n2 sin 20, which is equal to 0. So from here you will be directly getting the value of n3, which is going to be equal to n2 into cos 20 minus mu sin 20. So this is how you will be getting the value for your P, which is 58.77 Newton. So whenever you are considering a problem based on friction or in particular block friction, you have to understand that frictional forces are always going to be in opposition to the motion. So in your brain itself, or you should imagine that the bodies are moving and they are rubbing along each other, and then you have to understand the direction of the frictional forces in them. Once you get that particular idea right, then the solving part is quite easy for frictional forces. We will be taking up one more topic based on frictions in the next coming video. So if you are new to the channel, please do subscribe to our channel. Please do like the videos and do share it with your friends. Do let us know in the comment section how do you find these videos, whether they are helping you in your studies. And do write in the comment section what more videos you would like us to make on. So we are from Samartha Vidya classes, which is for engineering and science students. We conduct classes for the degree and diploma level students and also for the 11th and 12th PCMB group. We also help students for the preparation for the entrances exam. We'll be shortly uploading videos for the entrances exam preparation on this channel. So do let your friends know who are preparing for them. So for now, keep learning, keep watching, and happy learning. Bye.